Hello, we are Team Mike. Unfortunately, the guy that was going to do this talk hasn't turned up, so we're doing it. This isn't going to be very well practiced. So, our brief. We want to make a platform that allows you to distribute computations onto idle devices. So when they're charging overnight, you can make use of that power to do something useful. For example, do maybe protein folding or something like that. We haven't implemented that. We've made the framework and a couple of examples. So we're doing work over the network. We've made Twerk. All right. This is kind of the basic idea. So a customer gives us a computation. The server splits it up into lots of jobs. It sends them out to devices. They do the computation. We get the results back and collate it. So we've also built a web interface that lets us get results and as a demo. The server is actually built in Java. We use the Play framework with Postgres as the database. The web app is up. We were too cheap to buy a domain name, so we've got a short URL. Okay, so we can actually see the results coming back in real time. So, for example, we built an image filter system. You can upload images as the filters are applied on the phones. It gets sent back to the server and then sent back to you on the website. We've also done prime checking, so it splits up the range of numbers to check into several different jobs and splits them across phones. And the Android app.
The Android app is basically the fuel of the computation. It is very flexible because all the computation is basically done in one method, which can be implemented by an interface. And users can pick the computations to contribute to from the UI and also see how many jobs they performed and also see statistics. Also, since it is running on a phone, we need the users to have control over how the app is using the resources. So, for example, we have switches to turn off battery usage or mobile data. And, of course, we can share progress on Facebook. Processing of jobs can be seen in real time in the running computation section. And we can also see the live updating statistics. The app also provides statistics on a separate screen, which the users can look at to, for example, compare different days and compare statistics with users. We have achievements, and of course we have Facebook sharing, because if it's not on Facebook, then it didn't happen. The one thing that made the development quite easy is that the whole framework is very modular. So we have the server running separately, and the app itself can be split up into two main components. One is a service, which is running in the background, and one is the UI, which provides the settings and controls to this background service. And since it is a background service, the computations will persist even if the app is idle or the phone is idle and the application is running in the background. Again, since it is a mobile app, we let the users decide on whether they want to do computations only while charging, only on Wi-Fi, and if they do want to use the battery, they can set a minimum battery limit, and they can just turn it off completely if they want. Also, since the flexibility of the framework allowed us to make it very extensible, so the examples we provided were prime checking and image processing, but this is just a demonstration. Really, if anyone can write any parallelizable computation, it can be done on the system.
I think the other guy spoke much faster than we did, so we're running out of time. Used Play and Java. Something we can improve. We're not using encryption. That would probably be a good idea. I don't think it's too much effort. We're using a free Oars instance and web services. It's pretty limited in terms of RAM, so that's kind of actually limited what we can do. But it's free. Thank you.